For this problem, we have a 50-kilogram mining cart moving to the right at 5 meters per second on a horizontal track 30 meters from the ground. The track then slopes down, touches the ground, and rises back to a height of 10 meters where the track ends suddenly. The cart launches off the track at a 60-degree angle from horizontal and flies through the air as a projectile before hitting the ground. Assume there is neither friction nor drag. To find the velocity at which the cart launches off the track, we need to use our energy equation. So, our initial potential energy plus our initial kinetic energy is equal to our final potential energy plus our final kinetic energy. So, we use all our formulas for this. mg h initial for the potential energy plus 1/2 mv initial squared for the initial kinetic energy is equal to mg h final plus 1/2 mv final squared. So we can cross off the m's we can cancel out the m's and then plug in what we know, and we have v final as our unknown, and then if we just solve it out using algebra, we get our v final of 20.6 meters per second. To find the maximum height reached by the cart, we first need to break up the velocity found in part A into vertical and horizontal components. So we break down the velocity into its horizontal Vx and vertical Vy components using sine and cosine functions. So 20.6, which is the total velocity, times the sine of 60 gives us our vertical velocity of 17.8 meters per second, and our 20.6 total velocity times cosine of 60 is equal to 10.3 meters per second for our horizontal velocity. Now, to find the maximum height reached by the mining cart, we need to find the time it takes for the vertical velocity to become zero, because at the point that the vertical velocity becomes zero, the mining cart can no longer rise. So that's like the highest point that it can reach. So at Vf is equal to 0 and an initial velocity of 17.8 meters per second, which we just found is the initial vertical velocity, times a -10 acceleration due to gravity times the time, we come up with a time of 1.78 seconds, and then we plug that into another kinematics equation for distance traveled, and we get that and we plug in what we know about from that, and including the initial height of 10 meters, and then solve that out and get our maximum height of 25.8 meters. To find the total horizontal distance traveled by the cart, we need to find the total time that it's in the air using what we know about its vertical motion. So we plug in what we know into this into our kinematics equation using to find the total amount of time that's in the air. We're going to find the time it takes for it to go from its initial height of 10 meters to its ending height of 0 meters. So if we plug in everything that we know, we get a total time in the air of 4.1 seconds. Then we plug this into our kinematics equation for horizontal motion and plug in what we know. We know that it starts at 0 plus 10.3, which is our horizontal component that we found from breaking down the total velocity, times our total time in the air of 4.1 seconds, and there's no acceleration component because we assume that in projectile motion the horizontal velocity stays the same throughout, and then we just calculate that out using algebra and we get a total distance traveled of 42.2 meters.